Guys, we got a little Q-1-1 review here. Start with defining physics. So the definition of physics is the study of matter and energy. That's the first thing you should know in this class. First semester is matter, second semester is energy. Three fundamental quantities and units of physics would be the mass, kilogram, length, meter, time, and a second. What's the difference between quantities and units? Units tell us what quantity we're in, so in some sense they describe the quantity, or another way it would be to label the quantity to clue us in. Three derived quantities and units. So remember, there are many different options for derived. So we'll go through some of those options here. We start with the fundamentals, which is the kilogram, the meter, and the second. And then we just start building from there. We have meters squared, which is area. We have meters cubed, which is volume. We have kilogram over meter cubed, which is density. We have meters per second, which is speed or velocity. We have meters per second squared, which is acceleration. We have kilograms times meters per second squared, or a newton, which is force. And we have a kilogram times a meter per second, which is momentum. So there's 7. You only have to know 3, but you do have to know the quantities and the units. So we get into some dimensional analysis. So the first one is kind of surprisingly easy. You'll see what I mean in a minute. Say we have 115 kilograms over 1 liter. So first thing we do is get rid of kilograms and go to grams. So we have 1,000 grams in 1 kilogram. Now I need to go from liters to milliliters. I then go from milliliters to centimeters cubed. Check our math here. Liters cancel, milliliters cancel, kilograms cancel. We're left a gram over centimeter cubed. I just have to finish filling in our equivalencies. This is 1 in 1,000, and this is 1 to 1. So if you look, we're going to multiply by 1,000 and divide by 1,000. So basically, you just get the same thing again, which I know can be a little annoying, but whatever. We also have another problem they have to do a little bit more reading with. In this one, we have a pipe. And I'm not going to really start with pipes. I'm going to start with 2 hogsheads, and I'm going to figure out how many cubic meters that is. So there's my path. So we got 2 hogsheads over 1. Hogsheads goes on the bottom. It says a hogshead is 63 gallons. So 2 hogshead. The pipe is 2 hogsheads. 1 hogshead is 63 gallons. And then we go from gallons to inches cubed. 1 gallon is 231 inches cubed. And then we need to go from inches cubed to centimeters cubed. Normally there's 2.54 centimeters in an inch, but we need to cube that. And then we're going to go from centimeters cubed to meters cubed. And that's 1 and 1 e to the 6. So that's a pretty tough one. So we start working it out on our calculator here. Try to get a little closer for us. So we have 2 times 63 times 231 times 2.54 cubed divided by 1 e to the 6. So we get 0.47 meters cubed, which is the answer. Okay? That was probably the hardest one of the whole review. Then we have milli, little m, e negative 3. E to the 3 is little k, which is a kilo. And we have e to the 2, which is little c, centi. We move over here to this side. This is the symbol mu, which means micro, e to the negative 6th. Big M is mega, e to the 6th. Nano, little n, e to the negative 9. Time to plot some data. We're plotting position over time, meters over seconds. First position is 0, first time is 0. Then we have 1 and 2, somewhere over here. And then we have 2 and we have 4. We continue our plot. And then we have 6 and 3. And then we have 4 and 8. So you can see how we plot our data. We would say that this relationship would be linear. And then we want to draw a line of best fit. Now at this point, probably switch over to side tools, even though you probably know what the slope is, but just to be complete, I'll go through this process with you. So we want to go to the data graph wizard. We have our data, and we put in 0, 1, 2, 3, 4. So that's going to be L1 on our paper. I always like to mark what L1 is. And this will be L2, which is the time. L2 is 0. Whoops. L2 is 0, and 2, and 4, and 6, and 8. So now we have both of those two things. We're ready to quit this menu and go to the plot data. We want to hit the scatter plot. Remember, we chose the X to be L2, which is kind of backwards of the way you might think it would be. And now it mirrors what we have on here when I was on our calculator. At this point, we want to quit again, and we want to do a linear relationship, linreg, and we get that perfect line up through there. Hit y equals, and we get our equation. So y equals 0.5x plus 0. So rise over run is our slope, and so that would give us meters over second, which is velocity or speed. Now we get down here and we get to the measurement section of the review. If we want to define measurement, we would say labeling an object with numbers. And then it tells us two things. It tells us what a number is not and what tool we used. Now it's time to do some calculations. Remember, this got cut off. This is the theoretical, which is 8. And we want to go through and we want to first calculate our average. So we have 7.32 plus 8.53 plus 7.77. Get the sum, divide by 3. We have 7.87 for our average. Once we have our average, we can then do some calculations here. We still have to find our deviations. So we kind of look through here. It looks like our 8.53 is going to have the greatest deviation. 8.53 has a deviation of, we call it plus or minus number, 0.66. So that's positive 0.66. This one right here would be 0.42, and it would still be, it would be less than that for, whoops. So we'd have 7.87 minus 7.32, looks like it's 0.55. Well, anyway, it's less. And then 7.87 minus 7.77 is just 0.1. So it's less by 0.1. So this is our greatest deviation, so we want to pick that, plus 0.66. So if we want to find our uncertainty, what we want to do is take our deviation, 0.66, divide by the average, 7.87, and we end up with, multiply by 100, 8.4. It is positive as the greatest deviator was above. To find percent error, we want to take our actual value, which in this case will be the average, minus the theoretical value, which is 8, divided by 8 times 100. So we get negative 1.625 for that. And so that's the review. That's pretty much everything. If you have more questions, first video.